Hello, everyone. We're gonna just do more FE questions, basically. All right. A vessel is initially connected to a reservoir open to atmosphere. The connecting valve is then closed, and a vacuum. Let me just check if the audio is working actually, because that would be bad if it's not. It is working. What is the absolute pressure of the vessel? Assume standard atmosphere of the. Okay, so this is wonderful because this is basically doing something I taught my brother a little bit. So 1 atm is over here. If you want the vacuum. P vac, you minus it. If you're asking for P gauge, you're looking for this pressure over here. So what that means is that the absolute is this or this, depending on the relative pressure. Now, why do we choose 1 atm? 1 atm is the atmosphere of whatever world you are on. So most times you're in Earth's atmosphere. So Earth is 101 kilopascals. So I need to grab my calculator because I forgot my calculator somewhere. Um, Hold on 5 minutes. Here it is. Okay, so basically, I don't actually need a calculator here, I don't think, but the connecting valve is when the connecting valve is then closed and a vacuum of 65.5 kilopascals applied to the pressure. What's the absolute pressure of the vacuum, assuming standard atmosphere pressure? So you can immediately tell what it's trying to say. It's basically saying 101 minus 65.5. And grab your calculator because you will need it because you're doing 101 minus 65, which equals 36. So it must indeed be A. Now, a lot of questions here have tricks to them, but this one did not. I don't think, at least. It did not. So we can just put the A down and move on because that's the correct answer, I think. So after deleting all that, it should have shown up. Why is it not showing up? Did I not put A on top of there? A. Weird. Did I put it here? Yeah, I did. Okay, so for some reason it skipped one. What is the atmosphere pressure on the planet if the absolute pressure is 100 kilopascals and the gauge pressure is 90? So you got to think about it. Absolute is 100 over here. So the gauge pressure says it is 10. Well, that's interesting because that you can already understand that. Hmm, think about it. What you're supposed to get is ATM, right? So ATM must be this one over here because absolute it is 1 atm plus whatever gauge is equals absolute. So 100 minus 10 equals 90 kilopascals. So in that case, it should be C. Don't get confused by this. Actually, you generally will get confused. It is unlikely you won't get confused. That's kind of the logic of this question. Anyway, you can actually find all these questions in the description, hopefully. It's all public domain, I think, in the case how it was found. This, hopefully, I need to double check that. But anyway, 100 kilograms of water is mixed with 150 grams of another fluid. Density, okay, so water density, if you didn't know, you don't know because I never told you yet, is 1,000, I believe, kilograms per meter cubed. And the density of this new liquid is 790 kilograms per meter cubed. What is the specific volume of the resulting mixture? Assume that the volume are additive and the mixture is homogeneous. So think about the first thing. We need the volume first plus volume second, or the first and second liquid. So volume is by looking at mass, we can go density times volume. So volume is mass divided by 1, this is like this, plus mass 2 divided by density 2. Can we get our masses involved? Yes, it's 100 kilograms. So in this case, we have everything we need to get volume. But what's the specific volume is basically trying to get V equal 1 over density, which we can get density by doing some shenanigans with this thing, because this density will be mass 1 plus mass 2 divided by volume 1 plus volume 2. Now you can't separate these two easily because, I mean, you can separate them, but it would be 1 plus m2 divided by m plus m2, volume 1 plus volume 2, volume 1 plus volume 2. And I don't think you want to mess with all this stuff and try to complicate your life. Let's just leave it like this. For simplicity's sake, let's just not hurt our brains any longer, okay? Now, we have 100 kilograms divided by that plus okay, and 150 grams. Okay, so I choose grams because the answer is in grams per kilometer. So we have to change this into that form. If I remember correctly, the cm conversion rate, 1 cm is 100 cm equals 1 meter. So in this case, there's 1 meter, so it's going to be 1 divided by 100 cubed, right, on the top. And then 1 kilogram divided is 1,000 grams, right? So it's going to be 1,000 on top. So grab your calculator again, grab your calculator again because you will need it continuously. So grab your calculator and multiply 1,000 on the top by 100 cubed. Okay, so it is 1 divided by 1,000. So this is 1 for our water because it's divided by 1,000. Divided by 1,000 over here is, ooh, divided by 1,000 is about 0.79, which equals whatever that is. I have to just grab your calculator and add those up. I get about 289. Hopefully the numbers are correct. 289, and that would be wait a second, it's grams on the top and cm cubed. Beautifully done. As we do this confusing question, we move on to the getting the other parts of this question, which is basically saying we now know the total volume, 289. We know the mass is 100 plus 150. So we should get 100 plus 150 um, divided by 289, which equals about 0.865. That's none of the answers because this is density. You need to do the inverse of it. The second inverse of this question equals about 1.156, which we're going to round up to D. Now, here's a little trick of this question. This is not my first time doing this question. This is like my third time. Um, yeah. Do I think I would have gotten this question first off? No, because it's like, well, you need to understand what density really means, the homogeneous thing, and realize after that you have to look at the volumes, how to get those, then you have to look at this. After you do one of these questions, yes, then I think you can get it, but right off, nah, that's not likely. Okay, this okay, we're doing number three. We're doing basically we're doing specific gravity next, looks like. So 100 grams of water mixed with 150 of another fluid. What is the specific gravity of the resulting mixture, assuming the volume are additive and the mixture is homogeneous? So Ag is needed, and we already know the mixture's density, which was, I believe, if I look at the calculator again, it was equal to 0.865051903. So this was mixture of the fluid, which is equal to, uh, well, it's just a mix. I can't say it's a mixture of anything else. I can't additively do anything with that. So with that said, we can do density and density, and this is going to be at 4 OC, and then this is going to be whatever other temperature there, other vehicles there. So we already know that 1 is our density of the thing, so 0.8650519, because we realized earlier that dividing by 1,000 of the density gives you the right result. So, oh, I do hope that my face image didn't block out anything. That was horrible of me to have this open. I did not realize it again. It's like 15 time. Anyway, that would equal 0.865. So I'm thinking it's C. And hopefully that is correct. I'll delete all this for me. Okay, so now this is interesting because do you know your units? It's a good question. Kinetic viscosity can be expressed in which of the following kinetic is I mean I'll just say it's A. I know it's A. Sorry, it's A. But how do you know that? Well, kinetic. So what is kinetic? And then you should kind of figure out from there. That's the only way I could tell you, which is like, oh yeah, meter square per second. Like it's not. It's just there. I don't really have an excuse for it. You just have to know it. It's not. I mean, some of the professors know it every day and keep on telling you about it. So maybe from there you know, but other than that, you have no idea. Which of the following does not affect the rise or fall of a liquid in the diameter capillary tube? Okay, so this is another equation you have to kind of know. I'm not no, it's from the equation sheet, so it's fine to not know this actually. I take it back. I'm a fool for saying that. I'm so sorry to every individual that I said they need to know this. You do not need to know this. Look it up in the cheat sheet. It's called the FE exam something. Exam like booklet that has all the equations in, and this equation is in there. So we know from this the 4 is just a constant. So let's look at the other one. This is called tension. So that is surface tension. So that does affect it, right? Okay. So then beta is the angle. So angle does affect it. Rho is density. So density does affect it. And then G is gravity. And then D is distance. Okay. So what part of this is, I mean, I can tell you that the adhesion of the fluid and the cohesion of the fluid does matter. What doesn't matter is actually the viscosity of the fluid. Well, because if you look at the equation, adhesion force, and there's some forces here that you derive it. But if you don't know, well, it's fine. You're not gonna get this question, honestly. This question is kind of bonkers to bring. I mean, it makes sense once you know all the contents, but without knowing all the contents, like why? Like I don't. Yeah, it's fine to know it. I mean, it's a freebie for you if you know it. Yeah. So a film within a surface tension experiment is 10 centimeters. Is mercury as a fluid surface touches 0.52? What's the maximum force that can be applied to break the membrane? So this one is another, again, lookup. You need to actually know this equation in the lookup table. So if you look up at the table, there's called two types of things here. If you look over here, surface tension. If you read this, it says the surface tension of a skin that seems to be formed in the free surface of a fluid is caused by intermolecular cohesion, or is also known as surface tension. Surface tension is the reason that it intersects and able to polynomial surface tension also cause bubbles and droplets and form spheres since surface tension can be interpreted as a tensile force between 2 points of a unit apart of the surface of as the amount of work required to form a new unit of surface area in the a plot similar to that shown in figure 22.2. Typical units of surface tension are newtons per meter. So this was they're talking about this being a typical unit. And now from that you can kind of see the pressure shown figure. There's a figure that shows like this with a force over here, and this is L. Anyway, with that being said, the pressure shown in figure 22.2 consists of a wire frame with the uh so on and so forth. Frame with a sliding side that apply the dip liquid in the film. Surface tension is determined by measuring the force necessary to keep in one side stationary focused film. Since the film has two surfaces, the surface tension is equal to, this is equal to saying, surface tension equal F over 2L. This is called a wire framed apparatus. Alternative surface tension can be measured by um, measuring the force between the pull at the northern wave wire ring around the liquid as shown in figure 22.2. So another way of doing it is basically if you have something like this and a force, you have something like this, you have a liquid over here, all right? Shown in 22 because the ring inner and outer are in contact with the liquid, the wet parameter is twice the circumference of the surface. So basically what they're saying is this is equivalent to saying F over 2 pi R. Now we look at this image and which one it is this one. So it must be F to L. It can't be the other one because the other one makes no sense, right? So in that sense, let's grab our calculator because we have everything, right? I mean, we have our tension, surface tension is given, right? The film within the surface tension experiment is 10 centimeters. If mercury is the fluid, surface tension equals 0.52 newtons per meter. What is the maximum force that can be applied without breaking the membrane, neglect gravity? So F, and the reason why they neglect gravity, if you take a grad level class, there are certain things about it, but really don't care about that. Even grad class, they ever test you on it. They just tell you one day and then just move on. Either way, 0.52. I can't see any. There's probably a research person that does this all the time and does research on it, but I don't know. A lot of people are working on it, so we'll just move on. There's probably hundreds of people working on it, to be fair. Anyway, I get this is equal to saying F equal, actually, I should probably respect it more because of how often they work it. So it's A. Anyway, 0.1 is the answer. And this one is genuinely looking at the table, look at your cheat sheet and figure out the answer for you guys because there's no way you're going to actually solve this one. There's an FE cheat sheet that you're going to have to look at and figure it out. That's how you solve that one. There's no other way to solve it. Generally speaking, if they don't have an equation in the FE cheat sheet, all I say is give up because there's no way you're memorizing every equation because you have to look up your FE cheat sheet. There's a cheat sheet on the I forgot what it's called, instructional notepad. I have shown you multiple times that cheat sheet, and basically have like 200 equations there, like millions of equations, and you just Control F, find it, and then that's how you do it. Anyways, the cross section of a concrete dam is shown. The density is 248 thousand kilograms per meter cubed. The dam has a standard slope along the BC and its parabolic according to y equals 0.24 x squared along surface AD. Okay, what is the approximate mass of the concrete containing in a section of the wall? 1 meter bound? What the fuck? One with the in the cross-section area of 1 meter bound by point F, B, C. So F is here, B is here, and C is here. So you want the cross-sectional area of these cases. I think it's just a triangle, it's just an area, right? Um, you give me this is not even a fucking fluid question. I don't understand what you're doing to me, but it's unit width, right? So we can actually just say that's the area for this one because we already multiply it. So you can already say that 1 meter. I'm just trying to be more accurate here, but you can just say that if you want to shortcut it because it's unit width. It doesn't really matter either way. But basically it's 1/2 9 multiplied by 24, and then and that's it, I think. That's all you have to do, right? I'm not missing something special, right? Um, hopefully not, but I'll grab my calculator wherever it is and try to calculate it because this seems suspiciously easy for no reason. And don't expect your FE questions to have this kind of thing. Yeah, but something's probably wrong here. But I get 259, 259 to 000. It says mega. Woo, I never seen mega before, so it's huh. I forget what mega means. No, I do. What is this in? This is kilograms already. So it's already 1,000 more. So it's six of these over here. That's six of these, which means 259. So it's D. Okay, that's the trick. This is actually asking if you can do unit of conversion, which is hard on a test because you don't check those things often. So I understand the merit of this question. I don't like the merit of that question, but we could say there's a merit to the question now. So we go to the next question. What's the mass concentrated across the section in 1 meter around point A, D, and E? So this takes an integral over here because we need an area of this. So 0.224 x squared dx. This is your testing your ability to do integrals because you need area over here. Area equals, what is this? 0.25. Let's bracket this out. So there's an x cubed divided by 3, and there is a 0 to 10. And then that equals whatever that is. Alternatively, you could just grab your calculator and do 0.25 and do a second integral question from 0 to 10 to whatever this is. So this is x to the cube power. This is 625. 625 meters squared, actually. The volume equals that multiplied by 1. Right. Just to make sure this is... Oh, wait, I made a mistake here. Sorry. Um, this is I put this wrong. Sorry, my uh 83.33. There we go. That's the right one. I put a cube in my calculator instead of a square. Always make sure that your math makes sense because that didn't make sense because this was 30 and then 10 what times 10 is 1,000 divided by 3 was 300 and then minus 0 so it didn't and then multiplied by 1/4. So it has to be smaller than that. It makes sense. Anyways, 83 is our volume because you multiplied that by 1, which equals 83, and it's going to be meters cubed. We're just being more accurate with ourselves. And then we have to get our density involved, so 2400 multiplied by 83, whatever that equals. So we multiply what our answer is in our calculator with 2400. I get about, um, so, uh, well, I'm assuming it was my rounding error, so I think I'm gonna have to choose A. Probably a rounding error on my part. A. So next question is oil with a specific gravity of 0.72, which means it's density with density 4C, is used to indicate fluid in nanometer. If the differential pressure across the end of the nanometer is 7 kilopascal, what will be the difference of the oil in the nanometer? So, okay, so isn't this just getting the density of the oil? I think there's a nanometer equation, if I remember correctly, that we're gonna have to use actually because it's asking for the height. So, okay, so I'm gonna think about this question a little bit before I give you an answer in a nanometer. If there's an H over here, okay, I have an idea. So let's write out the Navier-Stokes. It might be crazy to do this, but density dt plus gradient thou density v. We know velocity is zero. We know density is zero. Then we write out the entire Navier-Stokes. This might be what you call overkill. Is v dot gradient. This is zero because it is no velocity. Negative gradient pressure plus gradient dot tau for simplicity. You could have written this equivalently as 2 mu gradient square, right? U plus mu plus lambda, I think is gradient v gradient dot v like that. But I wrote it this way, so we move on. Actually, there's no two here. Like anyway, and then plus rho g, right? And now we know this is zero because they're all velocity related. So minus gradient p plus rho g equals zero, right? Right. So with this said, we can do something quite interesting, right? Try to get h here, right? So how about we put in here, we'll integrate this because we are going to do the z direction. So in that z direction, pressure equals to about plus rho gz is a constant, right? So if you think about it, if you were to make a differential difference from rho 1 minus rho 2, you would be claiming P plus rho gz, and this will be differencing. So it would be saying P parentheses plus rho 1 1 gz1 minus parentheses P2 plus rho 2 gz2 2. So with that said, you can argue that the difference of pressure uh delta P, and it's going to be plus or minus depending on how you look at it. It doesn't really matter because it's the difference of pressure, so you can argue both ways. It doesn't matter. It's just relative to how you look at it. Rho 1 GH equals 0. So in this case, H equals delta P minus or plus. It just depends on your relative velocity, that one. G rho G. Yes. Yeah, that is quite accurate to say. And obviously this thing is the same density because it's using the not there's no two loop grids, so you're just minusing those two. Got it. Okay, so now all we have to do is figure out rho first. Rho equals SG multiplied by whatever 1000 is. So we can already indicate that rho equals about 720. With that 720, we can plug that into here. So with the pressure difference already found, which is 7, you can already say that 7 divided by 9.8 multiplied by 720 equals the answer. Okay. Why do I get 0.00099? Kilopascals. Kilopascals. So I have to multiply this by 1000. So that would equal 0.99 2063 meters. With that being said, we also know that these guys like to round up, so it must be D. Beautiful way to solve it. I refuse. So calm down. Okay, so it's D. With that said, it is D. That was a pretty hard question, in my opinion. I had to bring out the Navier-Stokes. Whenever you're mixed up in fluid, always bring out the Navier-Stokes. It is your king, your queen, your mate, your lover, your love of your entire life. That's what the Navier-Stokes is. There's something that you kiss and love forever. And also Reynolds transfer theorem is also very powerful. Do not forget that too. It does add up forces, but the Navier-Stokes is number one. You always love it, number one. You love it, you kiss it, you adopt it as your own daughter or son, and it is your lifeline. Very weird way to say it, but basically saying, it's everything in your life. Pressure of 35 kilopascals is measured 4 meters below the surface of an unknown liquid. What is the gravitation? Really? Really? Okay. So I'm not going to do the whole Navier-Stokes equation again. Obviously, it's just going to do rho g h instead. And then you're going to say, what is this? SG, right? You're going to get the specific gravity equal like rho water, right? And divided by and multiplied by rho h is what's going to happen because, this is changing over here. You're asking for specific gravity. Okay, okay, fair enough. I think we have everything, although. Yeah. So Sg equals P divided by rho water GH, which we could do like 35 1000 divided by 1000 multiplied by 9.8 multiplied by 4. So beautifully enough, we check mark that and we answer the question. So 1000 multiplied by 9.8 multiplied by 4, which is about 0.89285714.3. So we can get that as D. With that being said, I think we have one more question in this section. A dimensional analysis of a ship is being performed using a total of four different dimensions. Um, what is it? I can't read anymore. It's loading very slowly. Mass, length, time, and temperature. Six different variables: density, surface tension, viscosity, apart. How many identify as potential? Oh, this is the Buckman-Pi theorem. Effective velocity of the ball using the Buckman-Pi theorem. Okay, so here's the thing. We're gonna have to group things out. So basically, it's gonna be, if I remember correctly, it's k equal m minus n, where you say, okay, 1, 2, 3, 4. That's over here minus the things you need: 1, 2, 3, 4, 5, 6. So that equals 2. There we go. We need two of the groupings. So it is B. What B, not D. That would be horrible. But we're done. I think the next section is definitely going back to something else. So we're gonna stop recording here.